Welcome to Math 1314. This is section 2.6. In this section, we look at some basic functions. Really basic, really important functions that we will see often, so we need to remember what their graphs look like. Question 1 says, well, which one of all these graphs is the square root of x? Well, that's true. We want that, but I also want to talk about these others as well. Here is the square root of x. It starts at the origin. It goes off to the right forever. Now notice there is no left-hand side to it. And the reason for that is it's only defined for x's greater than or equal to 0. Because the square root of a negative number would be complex. So, square root of x starts at 0, goes off to the right. X cubed. X cubed looks like a snake. It works its way through the origin. It goes down and snakes its way up and grows. Absolute value of x looks like a V shape. It is a pointy V. It's always above the x-axis because the absolute value is always positive. And if you look at each one of these branches, this branch here is f of x equals x. It's just the diagonal line. Let's see if I can write that a little more clearly here. So this branch right here is f of x equals plain old x. It's just the diagonal line. Well, if that's the diagonal, then this one is simply the downward diagonal. It is f of x is minus 1 times x. So each of the branches makes a diagonal line on this V shape, which is absolute value. F of x is 1 over x. Has two branches. Now, what do I notice about it? Well, one, it blows up here at 0, which makes sense because 1 over 0 is undefined. So right here at this place, it's tearing. One side is running to plus infinity and the other minus infinity. And the two sides are pinching off to y equals 0. Here we have the cube root of x. Now, remember, square root up here had no left-hand side. But the cube root function does. It goes through the origin. It does kind of look similar to the square root, but this left-hand side is there. And that's okay because on the cube root function, when you have cube roots, so supposing I wanted to find, what if I wanted to find the cube root of 8? Cube root of positive 8. Well, cube root of positive 8 is 2. And the cube root of minus 8 is simply minus 2. That's why this left-hand side is under the x-axis. And here we have f of x is x squared. X squared is a U shape. Both sides are up, and it goes through the origin as well. Let's see, question 2 wanted us to find the cube root of x. Well, we know what that looks like now. So let's see, there's x cubed, absolute value. Oh, there's cube root, the one that goes through the origin, looks kind of like square root, but it has a left-hand side. Let's talk a little bit more about 1 over x. This place where it blows up, this vertical line is x equals 0. Goes through the origin. It's given a name. It's called the vertical asymptote. All right, in question 3, we're looking for x cubed. Let's see, x cubed. I remember that's the snake one. Let's see. Here's the snake one here in part C. The snake one that starts down, goes through the origin, and then goes up. Now, if you look at 1 over x again, we're talking about that because eventually we'll look at this class of functions, which are called the rational functions. Notice the ends level off, and it levels off to y equals 0. This is called a horizontal asymptote. Horizontal, where it levels off to on the two sides. The vertical is where it blows up. All right, question 4. Let's see. F of x is x squared. I think I remember that. That's that U-shaped guy. Yes, it's the U-shaped parabola where the lowest point is sitting here at the origin. So x squared, lowest point is 0 and then grows on the two sides. Let's see, question 5, absolute value. That was that V-shaped pointy one. Let's see, V-shaped pointy one, no, 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 no. Oh, there it is. There's the V-shaped pointy one. That's the absolute value of x. 1 over x. That's the one we talked about so much. The one that has a vertical asymptote at the origin and levels off on the two sides. Let's see. No, 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 no. Yes, there it is. No problem. All right, now in question 7 we get something new. They want us to figure out what does absolute value of x plus 3 look like. Well, absolute value is a V shape. Now I want to look at all the possibilities. What if I add 2 or subtract 2? And notice where I'm doing it. I'm doing it outside of the absolute value. And in these two cases, I'm adding 2 and subtracting 2 on the inside. So where it is happening matters quite a lot. If it's on the outside, then you take the whole graph, your basic shape, and simply move it up by 2. If it's minus 2 on the end, take the whole graph just like it is. Don't change its shape, just drag it down by 2, and the pointy part would be sitting here at minus 2. Now, if it's on the inside, if the outside is an up or down, then an inside is a left or right. Now the question is, well, which way? And it doesn't go in the way that you might think it should. When you see x plus 2, you're thinking, oh, it goes to the right by 2. But it doesn't. And the way to remember is, ask yourself what makes the inside equal to 0. So x plus 2 equals 0. I get x is minus 2. And so we move to the left by 2. Here, when it's x minus 2, let's see, then x minus 2 is 0. I get x is 2. And so it actually shifts to the right by 2. So now that we know all this, we've got absolute value of x plus 3. Well, I see it's on the outside. It's just like the plus 2 and minus 2. So it's going to grab my basic shape and move up by 3. So let's take a look. All right, so here is absolute value in blue. It is crossing here at the origin, so that point goes up by 3. All of these branches, so where was this? This was at minus 1, 1. It now goes up by 3 to 4. And similarly, you could take any dot that you like and go up by 3. And that would be the picture of our new shape. All right, in question 8 here. Let's see, I've got g of x is 1 over x minus 3. All right, so we know what it looks like. It's 1 over x, so it has that vertical asymptote thingy at the origin, levels off on the two sides to y equals 0. So let's see in this case. Add 3 on the outside, up by 3. If it's minus 3 on the outside, down by 3. If it's sitting there with the x and it's x plus 3, well, what makes it 0 is minus 3, so it would go left by 3. In this one, with the minus 3 down with the x, what makes it 0 is 3, so it would go right by 3. But in our case, down by 3. Alright, so if I'm just going straight down, then the vertical asymptote is not going to change. It used to level off at 0, on a height of 0 on the two sides. So if I drag everything down, it's now going to level off at minus 3. So just take the basic shape, drag it down, so it's leveling off on both sides to minus 3. Let's see, question 9. Okay, I've got an absolute value. That's a v. Something's on the inside, so it's a left or right. We know to figure out what makes it equal to 0. So let's see, that would be x is minus 3. So the whole graph just moves left by 3. Used to be at 0, 0, now moves over to minus 3, 0. This was at minus 1, 1, moves over by 3 to a minus 4, 1. So similarly, all of these points just get moved to the left by 3. Question 10, let's see. We got a cube root. All right. We know what the cube root looks like. Looked kind of like a square root, but it had a left-hand side. This plus 4 is on the inside, so that is a left or right. So x plus 4 is 0. I get x is minus 4. So I go left by 4. So let's see. Where's my shape? All right, here's the one they drew in blue. I'm going to go left by 4. So let's see. Here's the origin. Left by 4. Minus 4, 0. And then looking at my sad shape here of a graph in red, I try to make everything move to the left by 4. In Connect Math, you just drag the graph over and it maintains its shape, so it's a bit easier. In question 11, we have now two things going on. First, it's a square root. All Alright, I've got something on the outside which is minus 4. The minus 4 on the outside is going to go down by 4. And this something on the inside, what makes it 0 is minus 2. So I'm going left by 2, down by 4. Alright, so let's see. 0, 0, which is here, left by 2, down by 4. And so the starting point is at minus 2, minus 4, and then it continues its shape. So again, left 2, down by 4. All right, question 12. We have 1 over x, the one that has the vertical asymptote at the origin. Let's see what's going on. The plus 1 shifts the whole graph up by 1. Here's something inside with the x. So that's a left or right. What makes it equal to 0 is 3. So right by 3. Okay, so if it used to be blowing up here at the origin and I go right by 3, it now will be tearing and running off to plus and minus infinity at the vertical line. X is equal to 3. What else? Well, let's see. It used to be leveling off to y equals 0 on two sides. But since it's moved up by 1, it's now going to be leveling off on both sides to y is equal to 1. So knowing just a few basic shapes, it's easy to shift it around. And question 13. Now 13 introduces something a little different. They want us to figure out cube root of negative x. Alright, well let's see. First off, if I have x squared or u-shaped, if I put a negative in the front of the whole thing, that's minus 1 times x squared. So putting a negative in the front of any of our basic shapes is going to flip it on the x-axis. So it used to look up, and if I flip it down, it looks like that. If I put the minus on the inside, so here the minus 1 was on the outside, here I'm putting it inside of the squaring. The effect is it's going to flip it on the y-axis. But if you look at our shape, it won't matter if we flip this around. It's symmetrical or the same on both sides. And you see that because minus x squared is minus x times minus x, which is an x squared. So here is our cube root of x. If I put a minus on the inside, it's going to flip it on the y-axis. Alright, so let's see, what does that mean? Well, the origin would not get flipped anywhere. This side, if I flip it around this way, should come looking like the following. And similarly, the bottom that goes this way, when it flips, it goes to the other side. And so here's my final picture. The one in blue is f of x is the cube root of x. The flipped one, so you see this part here, when I flip it around the y-axis, is going to look like this. And this part that's over here, when it flips, comes this way, And this is f of x is the cube root of minus x. So a minus on the inside flips us about the y-axis, and a minus on the outside flips us about the x-axis. Memorize the basic shapes, draw them on a piece of paper, keep them near you, and it'll make these problems a lot easier to do.